Okay, example number 2 here in algebra notes for exponential versus linear. So we're given 2 points and we're asked to consider the relationship that passes through the points 1 comma 8 and 2 comma 2. So first off, just by looking at these 2 points, is this enough to tell if this is an exponential relationship or a linear relationship? And it's actually not, because if you take a look at 2 points, it doesn't even matter where you put them. I can definitely connect those with a straight line and make something linear, absolutely. But I could also connect those with a curve and make something exponential out of it. So truth be told is that 2 points aren't really enough information to determine if something is actually exponential or linear. It's just not enough information. Which is why here in this example 2, we have a part A asking us to create a linear equation out of those points, and part B asking us to create an exponential equation. So starting with linear first. Linear, the first thing that should be jumping into my head is that y equals mx plus b, which in that I need to have the m and the b filled in, that slope and my y-intercept filled in. We'll have to deal with that later. So starting off with those points, I'm going to start by finding my slope, which I'm going to do by using change in y over change in x. So 8 minus 2 over 1 minus 2 is equal to 6 over negative 1, which is equal to negative 6. So that is my slope. And just like we practiced in the previous example, we're going to use one of those points that they gave us and the slope that we just found to solve for our missing y-intercept. So I'm going to go with the point 2, 2, just because it's a lot easier and I don't have to worry about messing up putting the wrong one in for x and the wrong one in for y. So y equals mx plus b. In for y, I'm putting 2. In for m, I'm putting negative 6. In for x, I'm putting 2. In plus b is staying plus b because that's what I'm trying to find. All right, so negative 6 times positive 2 is going to give me negative 12. Getting rid of that negative 12 would involve adding it to the other side. So b is equal to 14. So my final equation would be y equals negative 6x plus 14. And negative 6 makes sense as my slope because if I'm starting at 1 comma 8 and I'm going down to 2 comma 2, 8 from 2, that's showing that it's going negative, that it's decreasing. It also makes sense because I can take 8 and subtract 6 from it and get 2, which means that it makes sense that my y-intercept is 14, giving me that point 0 comma 14. Because if I have 1 comma 8 and my slope is 6, 14 minus 6 gets me that 8. Or going backwards, 8 plus 6 gets me that 14. I'm rambling. Okay, cutting it short. Boom. Linear equation created. That's a review. We've done that before. The exponential equation is going to be the new piece that we're going to look at. So exponential equation, hopefully what's going through your head is that y equals a times b raised to the x power. And here we are going to look at our points and realize that we're starting with 1 comma 8 and just like we said, going down from 8 to 2. Exponential tells me I need to have a multiplying factor, which means that there's something I need to multiply 8 by to get to 2. Well, 8 divided by 4 gets me 2. Dividing by 4 is the same thing as multiplying by 1/4. So this tells me that my base is 1/4, or my multiplying factor, which I'm going to use in my equation right away. So y equals, still don't know what the a is yet. Sorry. And the base is 1/4 and x. So we could do a little work backwards to get that y-intercept, or we could actually plug stuff in like we did in A and actually solve it. So I'm going to use the equation or the points 1 comma 8 on this one, just because it's a lot easier to work with an exponent of 1 than it is of 2. So 8 is equal to a parentheses 1/4 to the first power. 1/4 to the first power just stays as 1/4, so 1/4 times a, or 1/4 a. I get rid of that multiplication of 1/4 by multiplying by the reciprocal, which leaves me with an a value of 8 times 4, which is 32. Which makes sense because if I'm working backwards here, I had to multiply by 4. From 2 to get to 8, I did times 4. 8 times 4 would give me that 32. Going back to the initial thing that we wrote down, it's all about looking for those patterns. And if not, then you can always rely on good old algebra to help you out. And your final equation is y equals my a value, or my y-intercept, times 1/4 to the x power. I'm just going to clean up that 1/4 a little bit because it looks a little sketch. And there we have it, peeps. Bon voyage.